Hey folks, Quilly18 here, and welcome to another episode of our Unity tutorial about networking. We are using the Unity networking system, sometimes called UNet, and we are trying to go above and beyond the tutorials for the multiplayer that are available on the Unity website, which are very quick, but leave a lot of holes in the explanation and actually leave you something that's not particularly extensible. So anyway, last time we left off our code, we're trying to get to the point. We've got this player object. This player object automatically gets spawned in the network whenever a player connects. But this player object, because of various reasons, I want this to be not something that's actually a part of the game. I don't want this to have a physical presence. It just represents the player's connection and information and that sort of thing. Because this might be a game where the player literally doesn't have a physical presence in the game. For example, something like Civilization or StarCraft. Like, you don't personally exist in the game, so it doesn't make sense to have an object that represents you. But even in the case of a third or first-person shooter or something like that, where you are sort of physically present in the game, it still sort of makes sense to have a distinction between the player connection object and the actual physical object that's running around the world that might get destroyed and despawn and have to be recreated. Whereas recreating the player object gets a little bit funky, and we want to avoid that. So, we are now in the state where we're verifying that this player object gets spawned in. Keep in mind there's going to be one player object for each player connected to the server. And on each individual client, so let's say there's like 16 players connected to the server. On each one of those 16 players, they each have 16 player objects present. You know, one for themselves and 15 for everyone else. And each one of those will run the start function. So what we're doing is we're checking to see, is the player object that's running start, is that actually ours, or is it someone else's? If it's someone else's, we might still decide to do something at some point, but right now we're just bailing. And then what we want to do is we want to spawn our actual physical player unit on the map. We want to make a Zergling or something like that. So we have, our debug log here, and we could instantiate, but instantiate, as we talked about last time, only creates a copy of the game object on your personal computer. It's never present on the network in any way whatsoever. Now, this is still very, very useful for things like anything that's not network. For example, you might do a special effect. You might do like a big explosion that's not part of the network, just a special effect. You just want to have like fireworks going off in the sky or something the whole time. None of that has to be synchronized in the network. You don't have to like coordinate the position of the fireworks in the sky for just a visual effect. No, so you just instantiate it on the local client. It just does its thing, and that's okay. And everything else on the network, they're doing their own thing, and that's fine. But this is, this is our Zergling that's going to be running around on the map. Therefore, it has to be instantiated on everyone's computer at the same time in the same place. It has to be enabled for networking so you can move it around. So the only person allowed to create something on an object is the server. So what we have to do, instead of doing this, boop, boop, ask the server, actually it's command, politely, the server to create, to spawn, actually a magic word, our unit. So how do we ask the server to do that? Well, what Unity networking has done for us, I'm going to go down here after the update. Remember, update runs on everyone's computer, whether or not they own this particular player object. So again, you might want to check to see, hey, is this object owned by the local player? Yes, no. Maybe you want to do different things depending on the case. Maybe you just want to return right away if it's not owned by me, etc. Keep that in mind. Okay, so we'll make a section. So you want to make a big section over here. Commands. Now, commands are special functions that only get executed on the server. So let's say we make a function called something like spawn my unit. Okay? So this is just a function, and you can call it from anywhere. So over here, we could call something like spawn my unit. And you just call it like that. Now this by itself, we'll just call this function. And again, we're still on our own computer, right? If I'm on my computer and I call this, then it's going to run spawn my unit on my computer. How do I get this to run on the server? Well, what you do is you just add this command attribute like this. And by doing that, Unity takes care of it for you. When I call this on my computer, it actually executes this on the server, like magic. Now, there's going to be an error here, compiling error. If I go out here, it'll tell me command function spawn my unit does not have the CMD prefix. I don't think there's any technical reason this needed to be in there. I think this was just a decision by the Unity people to make it more explicit when you're using a command. All command functions have to start with CMD. There you go. They just do. So now, when I call command spawn my unit, this gets sent to the server. And now, we are guaranteed, damn it, to be on the server right now. Bam. So, if we've got that, now it's worth noting, you can only call command spawn my unit on things where you have actual authority, which by default will happen on your player thing. We never did click on the player object, the local player authority thing, and I'm still waiting for an error to happen as a result of that, but we're going to keep going until that's the case. At some point, I suspect we will actually have to hit this button, but we're going to try to delay that as long as possible because we learn from errors. Okay, so we are guaranteed to be on the server right now. So how do we make a unit? Well, we still start by instantiating. Now, keep in mind, even though we're on the server, this is still the same script, and it's still set up on Unity. Each computer has the same Unity project with everything organized the same way, the same links to prefabs, and so on and so forth. So on the server, it still has this link to the player unit prefab, and we still start by instantiating on the server. But what we have to do is we have to just hold on to it for a second, like this. And man, am I so happy that they've got the templated version of instantiate. I don't know when that got added in, but it's so nice to not have to cast anything. So we just grab a copy of the game object, because then what we want to do, now that the object exists on the server, propagate it to all the clients, and also wire up the network identity, which we're going to get an error because we don't have one right now. But call network server dot spawn. So later on we'll be using spawn with client authority, but let's hold off on that for a second. Spawn, and we just pass it a game object. So by doing this, we now go and spread this game object all over the network. Except when we try to do it, we will get an error. Now, I think this is my old error. This should go away. I think if we did it now, we actually wouldn't get an error if I run it just locally here. If I go LAN host, I create a server. Oh, okay. Well, we get an error. We're going to get another error in a second. So I'm running my server myself. So the client went and told the server, i.e. myself, to please spawn this unit. And the server ran the instantiate. The instantiate step ran fine, but we get an error on the network server.spawn step because this prefab doesn't have a network identity. So we have to add a network identity. Boom, like that. Now, if I hit play again, and again, I'm going to do hosts on both the server and the client, everything seems to work fine. Okay? The server gets the command to create this unit. It instantiates it and then calls network server.spawn on it to communicate this to everyone else on the network. And it looks like it's working fine, but it turns out there's something broken. I will show you what it is by doing a build and run over here. And in the standalone executable here, the exe is going to be the server. And then the project in the Unity editor will connect to it as a client, and we'll get a nice big fat error message. So this is going to be a host and a client, because why not? And although it could have just been a dedicated server, and we get just the same exact error. And then this will connect as a client, and we'll get two lovely errors. Boom. Failed to spawn server object. Did you forget to add it to the network manager? Then we get spawning my own personal unit. Then we get the same error message again. When we connect to the server, the first thing the server does is, it spawns our own personal player object. It also spawns a copy of the other guy. Remember, this window here, he's also a client. There's two players right now. So we get two copies of the player object. But then the server says, hey, I'm also supposed to spawn two of these units. One was already existing on the server from when he created his own. And then when I connect, I then ask the server, hey, can you spawn me a unit? And the server tries to, but we get these errors. Now, it actually works fine on the server window. You can't tell, but there's actually 2 balls over here because instantiate works fine. The problem is the step where it tries to spawn the object on all the clients fails. And the reason for that is anything that is spawnable in your game, you got to go Network Manager, the spawn info over here, anything that can be spawned has to be in this list of prefabs. Now, you don't have to put the player object in here because it's part of the player prefab, but we do have to put in the player unit. We have to say, this is a thing that can be spawned. Basically, this is going to be spawnable thing number 0, right? Like 0th thing in this array. Because what network server.spawn, right? What network server.spawn does is it tells the client, spawnable object number 0 in this list. That's how they communicate which is which. So now if we do this, and we just did a Control B to build and run, chugga. If there's a faster way to like get the stuff to compile, man, I would be happy with that. Start it over here, just pop back over here. So again, I'll run this as the host and client. So it's both a server and a client, so it spawns its own unit. And here we're going to connect to it. No more error messages. And you can see, oh, that's just the message. When I tab in and out, it lets you know that, hey, the network's still going to run. I spawn my own personal unit. But if we look, we've got 2 player objects, and we've also got 2 player units in there. How wonderful is that? So everything has been properly spawned on the network. Now, right now, they don't have any sort of like linked behavior or logic. That's going to be the next step. But we are correctly spawning things on the server over here, like so. Awesome. Groovy. I think I'm going to leave these notes in here. End up with a lot of comments here, but I think that's going to be okay and handy. So the next thing we want to do is we want to be able to say, move our unit around. Let's add a script to our unit. And again, we're going to run into a handful more disasters. Kill you over here. So in Unity, I'm going to create, let's create another C# script for player unit. Instead of player object, I probably should have called it player connection or something, but oh well. I want to be consistent with the internal naming, but I think it's less clear because player object versus player unit. I could have just called this one Zergling or something. Although, you know, copyright issues. I don't know. Anyway. So we've got a player unit script. Okay? So this is... Why are you all in red? There we go. Thank you. A player unit is a unit controlled by a player. This could be a character in an FPS, a Zergling in a RTS, or a Scout in a turn-based strategy. TBS? Real-time strategy, turn-based strategy? Something like that. You know, any kind of unit like that. Now, we want to be able to move this. So what I want to do is kind of a standard thing. Let's say when we hit the space bar, the unit moves up by 1 unit. Very, very simple little piece of code. So if input dot get key down key code dot space. There we go. So if on this frame the space bar was pushed down, we want to move up by 1 unit. So this dot transform dot translate. Can we do an XY? Yeah, there we go. So upwards in the y-axis by 1 unit. Done. So let's give that a quick little test. So we hit play. We'll host our own, hit spacebar. Awesome. Now, this is not being synchronized on the network. If I went and started the standalone thing, well, actually, there'd be 2 problems going on. You know what, then? I will demonstrate that, because why not? Demonstrating problem. I hate that there's, like, this extra little step of building it, and everything takes just a little bit more time. Chugga. It doesn't actually matter for this example which one's the client and which one's the server. Let's have this one be the server. I don't think it matters. So you connect there, and you connect as a client. And so we have 2 player units in here. I'm going to shove one to the side like that. Now, first of all, when I shove this to the side over like this, notice that nothing has changed over here. They're still in the same place. That's one problem. The other problem is when I hit spacebar here, both balls move upwards. So there's a couple of different problems going on. First of all, remember that this update, this function runs on all player units, not just the ones that I own. Now this, what we're changing here is not networked. It's only happening on my local client, which is why it's letting me move both, even though I don't own both. Because again, it's just Unity. You can like take any object and move it around on your computer. It's not going to affect anyone else's computer, but you can do whatever you want with stuff on your computer. It's not going to make sense networked. So it's letting us do that, but it's breaking things, so that's bad. But yeah, so first we want to do, hey, is this our object? So again, if we want to check to make sure that this is our object, then what do we have to do? Well, we have to go and add the networking namespace just to make it a little easier for us. We want this to be a network behavior. And then what we did before is something like if is local player equals false, return. Now that I don't believe will work. At least, unless I've mistaken about something about how things get set up, this should not work. Although we are going to be on server, so if I hit spacebar, there we go. Nothing's happening. Why is that? Well, is local player only gets set to true on your one and only player object, the connection, the thing that gets spawned by the network manager. That is the only thing for which is local player is true. Nothing else is. That's one part of the problem. But the other part of the problem is the server happily went and spawned this player unit, right? This player unit was spawned on the server. And that's it. The server never told anyone that they actually own this unit. As far as the server is concerned, only the server has the ability to modify this unit, and that's it. And the server could. I mean, there's no reason it couldn't. I mean, we could do something like, this would be weird. I could say something like, is server. So now, if you're actually the server, then you're allowed to hit spacebar and move these balls up. But that doesn't make any sense, because the server isn't a player. I mean, sometimes you are both the client and the server, but being the server doesn't mean you get to do anything. So how do we check? How do I verify that I am allowed to mess around with this object? Question mark. Now there's a few different ways to do this actually. I'm gonna go and put the is local player back just so that it compiles. There's a few different ways to do it. Player object. There's no reason in player object. Keep in mind, in here I could run some sort of code in player object, right? Player object over here. Again, we could sec, so is local player equals false, will return. And then we could check the key down. So, spacebar was hit. We could instruct the server to do something with our unit. That is absolutely a valid way to communicate things. To do this, but there's always going to be a little latency because you're going to have to wait for the server to get this message and then for the response to come back to you. So depending on what kind of game and what kind of your interface you're making, usually you want your unit to respond instantly when you make a move, not wait for like the latency to happen with the server. But for some games, this is 100% a correct and perfectly fine way to do things. As long as you've got some way to link in here what my object was, like what is the correct my unit. Maybe the server knows the answer, maybe it doesn't, and it could. And actually, we could use a sync bar for this, but let's come back to this. Wow. Okay. So none of this code. Okay, so this is in player unit. None of this code works right now. So let's just take all this and comment it out, just to be explicit. None of the code in player unit works. What we could do on the server, we could keep track. So we can have a variable. Now this variable, so if I have something like game object, my player unit. Now this is a variable that exists just in this script, and it exists on the player and everything. That's fine, but normally it'll be set to null. But on the server, what we're going to do is we could set my player unit to be equal to this game object. I mean, there's lots of ways we could keep track of this stuff, but for now we're just going to go and assign it this way. And then what we could do is something like this. We could make a new command void cmd move unit up, like this. And we could do something like if my player unit is equal to null, then we just return, right? Just in case. But otherwise, then we can do, my player unit dot transform dot translate 0, 1, 0, like this. So then, again, this is in player object. We could say, hey server, could you please move my unit up? And this will work. Now, again, remember, player unit over here effectively has no code. The only code that's existing is in the player object over here. And the player object is invisible, is a nothing, right? The player unit, the sphere, is some other thing completely that's being created over here. We keep a reference to it, and then we're going to try to move it. So if I go and hit play, and hit spacebar, we send a message to the server asking the server to move my ball. And then the server is moving the ball. Now, we're not 100% there yet. Let me go and do another standalone player example here. So we're going to start the server over here. So this is going to be the host, and we have and ball over here. If I move this ball before the other client connects, it'll actually be in a different position, which will be nice. So we'll do this. So you are going to play, and you're going to connect. There you go. So it actually, like, when you connect, it gets the correct location of the object, but that's about it. If I hit spacebar over here, we're not going to see anything move here. Because what I'm going to do when I hit spacebar, I'm going to ask the server to move that ball for me. And the server will move the ball. You're going to see it right over there. See? The server is moving my ball upwards. But we're not communicating that change in location back over here. Let's fix that. So on our player unit, what we want to do is we want to synchronize the transform. Now, we could write code for that. It would be very easy for us to write some code that synchronizes the transform. But basically, the server, whenever the object's position on the server changes, we then send a message to all the clients using an RPC call, which we'll do later, to tell it to update the transform. However, to save our sanity, there's a very nice network transform component already made for us. Again, it's not magic. We could write our own. But if we add that, by default, it checks 9 times per second is the default number. You can change that. It checks to see if the transform has changed. It could also track rigid bodies and other things like that, but the transform is usually fine. If the position of that transform has changed, then it will send that to the client. So it's checking this on the server, and it will tell all the clients that it has moved. So we're going to go ahead and do one more little example over here. So again, my client is not moving the ball directly. My client is simply asking the server, hey, could you please move this ball for me? And the server is going to move the ball, and then after it's moved again, I'm going to take this thing and just shove it over to the left before we connect on the client, so they'll be in different positions. And then after the client moves the ball, the network transform will automatically send that information back to the client. So I'm going to hit spacebar here. There you go. You can see there's just a little bit of latency. Even on my local network, even on my LAN, there's a tiny lag between sending the information to the server and it coming back, because it sort of only does the sync, well, again, 9 times per second. And it may, there may be a frame delay as well that happens for sometimes, but I hit space, I ask the server to move the ball, the server moves the ball, and the network transform comes back over here and says, oh, hey, the position of the ball changed, here you go. And that's it. As far as I know, network transform does not use any bandwidth if there's no changes happening. Now, so that's an way to do it. But maybe we want instantaneous response. On our client, we don't want to wait until the server does their whole round trip message. We want our client to be allowed to move its own object so that it gets instant response. Now, keep in mind, you might still want the server to double check that all these moves stay legal. And if it's somehow the client ends up doing something it's not supposed to, the server can still force the object to go back to a legal position. But you probably want the player's unit to move right away. So Instead of having the player object listen for a mouse and then send a command to the server, we're going to go back into the player unit over here. And again, we want the player unit that when we hit the space bar to do something. But the problem is, how do we know that we're only running this code for the thing we're supposed to move? Well, there's a trait called has authority. Has authority is true if this is an object that I personally on my computer am allowed to screw around with. If has authority is true, I'm allowed to mess with this object directly. And then have those changes be propagated to the network, which, for example, would happen through the network transform. So if has authority were true, then I'm allowed to move this bad boy. So how do we get the authority to be true on this object? Well, there's a bunch of different ways. When we spawn an object, we can get a copy of its get component player, network identity, and it's authority something. Assign client authority, and we pass it a network connection. Connection to client. Connection to client is a link that belongs to our network behavior that points to the person that owns this player object. Okay? So if we did this, we would tell this game object that the thing that has authority over you is this client over here. Alternatively, and this is perfectly legit, alternatively, and I don't remember if we have to do this before or after the spawn. We might need to double check. It may not matter, because this can change at runtime. Alternatively, over here, instead of calling spawn, we can call spawn with client authority, and it's the same thing. We just pass it connection to client. So now we've told everyone on the entire game server, we've told everyone in the entire game server that one particular person owns this. So now all of a sudden, I should have authority over my own object, and this code should work. Let's see if I've done this right. There's a good chance I didn't. Hit play. So I'm just going to do my own. If I hit, whoop, can only be used for network identity components. Oh, local player authority set. Okay, so this is the first time we've hit this little issue over here. One second, before I go any further, does it have to be set on this one or the other one? Okay, it has to be set on the other one. So this network identity needs a little checkbox here to say that the local player has authority over this object. Now, it's funny because hang on a sec. I feel like something is misnamed here. I'm just checking something, and then I'll try to explain it after. Yeah, there we go. So even though, and that's what I thought, even though that local player authority checkbox is on, no one is considered to be the local player authority on this object right now. Okay. It seems redundant to have the two, though. Like, I don't know why you need to check the checkbox if you're doing this, because it feels like this is almost implied. Okay, let's see now if this will work. Yay! Okay. And we'll double check that it's working with the standalone client. But what should be happening, and yeah, we'll double check 100% sure that we're happy with how things are with the standalone client, but what should be happening is we can now move only one of the balls. So I'm going to host here. Again, I'm going to take this guy and just move him slightly over to the left. Then I will go over here, play here, chugga, chugga, chugga. I will connect. Now if I hit space over here, this is my object, and I can move it, and it moves instantly. In fact, it moves faster here than on the server, although it's really hard to tell. And if I'm on the server, well, again, the server, which is also a client. So now I'm thinking about from this client, if I hit spacebar, I only move this one. Because this ball on the left is owned by this client, and this ball on the right is owned by this one. So they only respond to the appropriate key inputs like that. And that's without being the actual player object that gets spawned by the network manager. And that, I think, is very, very powerful. So we're still in a position where we get to directly control one object, but it's not the player object that's kind of our network connection. Again, I feel like this should be renamed. I'm just going to do it. I'm going to call this player connection object instead. I like that better. Boom. There you go. Just hit F2, player connection object over here, like that. Makes it way, way, way more explicit what the hell we're saying. Okay? Hopefully I didn't break anything. I don't think we did. Because you're fine. Oh, again, I'll rename this. Oh, no, you did lose the component. I'll rename this object, player connection object, and it did lose that script. I guess I can't change it. Remove. Slide over. And the prefab is back over there. And the network manager, you're still good. So if we hit this, yeah, I like that much better. Okay. So we have the player connection object, but it's not something that exists in the game world. And I think that's wonderful. Wonderful. And then we're spawning a player unit, and we're allowed to mess with the player unit directly. But if this player unit gets destroyed, if input.getKeyDown is the key code D, or here, the delete key. You know what? That's a little dangerous in the editor. Let's just use D. Then we destroy game object. And I believe this will correctly destroy on the network as well. But it means we don't lose our connection, because, right? So move up, hit D, destroys that. But my player connection object is still here. And in my player connection object, maybe now, I have, in my update, the S, we'll call command spawn my unit. Although this will override the old one, but, you know, let's pretend. There you go. Spacebar to go up. S or D to delete. S to spawn a new one. Move up. I'll spawn another one. This will break. Oh, that's right. Yeah. Boop, 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 boop. There. There you go. These are because I thought it was going to break the spacebar command, but it would have broken this one because of how we're saving a reference to the player unit. Which I'm actually going to get rid of and clean up now. But each one of the player units is running its own code over here. They all confirm that they're owned by the right person, and that's that. And again, if we check with the standalone version, actually, before we make the standalone version, cancel. I'm going to get rid of the code in player connection object. So my player unit goes away, that goes away, and this command can go away as well. Boop. Okay. Build. Come on. There you go. Hit play over there. Run this. Start the server. Connect. Spawn. And actually, one of the things you can do is on the server here, there's nothing stopping me from moving things in the editor view. And it actually does, because we've got the network transform on there, it does move things over here as well, which is kind of spiffy and fun to do. So there we go. So we have, and there's nothing stopping us. Well, clearly, we already have multiple objects. When I hit that S key multiple times, I have multiple objects, and they're all listening to my keyboard inputs. Now, if those were all Zerglings, obviously we don't want them moving up by one unit every time I click. Instead, they're probably going to have their own little AI for like not bunching up. And then if I select them and I right-click somewhere, then they'll all run in that location together using sort of AI movement instead of being, manually moved by the keyboard. But still, as long as they've got their player transform or the network transform on there, the position's going to be updated in real time on everyone else's client connection. We're going to want to sync up some of the animations and things and whatnot. Although, actually, I don't think there's any real need to sync up the animations. It doesn't matter if that sort of walk cycle is in sync on everyone's computer. Who cares? As long as the other computer knows, well, this Zergling is moving, then it can be responsible for handling its animation in its own state. There's no reason that has to be networked, although you can network things. The next thing we're going to do for some of that, including things like starting and stopping animations, is looking at RPCs. RPCs, remote procedure calls, are just like commands, except they only ever get run on clients instead of on servers. We're also going to look at sync vals. But that's going to have to wait until next time. Thank you very much for watching, folks, and I will see you guys next time. thank you to all the January Patreon supporters and these Mic Check supporters at Yukofin, Lurking Ninja, Dubiouser Curl, Tiburon, Mighty Mix, Pavel Zdanov, Adam Keenan, Michael McClintock, Aaron Doibson, Rarskal, Gurko Dries, Jesper Bisgard, Julien Gelafon, Soren Tried Anderson, Marisfield Vold, Speedy Savant, Steven Stager, Thomas Oberson, Jason Yanity, Easter Egg Productions, Neil Blakey, Milner, and everyone who watched, shared, favorited, and subscribed. Thank you so very much.